Welcome to this summary of Chapter 1 of Scaling Fisheries. Fluctuation is the very essence of ecosystems. We will explore the historical and scientific considerations regarding the variability of fishery resources. Ecosystem dynamics is based on the idea that an ecosystem results from the integration of multiple species in a shared environment. As Margoleff noted in 1960, ecosystems are never static. Fluctuation is their very essence. In the 19th century, fluctuations in fishing yields caused economic instability and investment risks. Traditional explanations included fish migration, climate change, and even religious factors. However, systematic analysis of the root causes was lacking before the 1860s. Four main hypotheses emerged to explain the variability in catch: migration, pollution or disruption of breeding grounds, predation by large animals, and overfishing, which exceeds the reproductive limits of the fish stock. Let's begin with Case Study 1, the Lofoten Island cod. This case highlights the challenges faced by local fisheries due to fluctuating yields. The Lofoten cod fishery was vital to northern Norway's economy. Failure meant famine and defaults for banks. GOSARS began investigations in 1864, collecting detailed statistics and discovering that cod eggs drifted with the ocean currents. The 19th century Lofoten cod catch shows significant fluctuation. Starting strong in 1860 with 24 million fish, the catch increased until 1875, maintained an average until 1897, then plummeted below 10 million by 1900. This drop caused an economic disaster. Case Study 2 looks at La Crise sardinière, or the sardine crisis. This event demonstrates the devastating impact of resource collapse on a regional industry. The sardine crisis saw an 80% decline in catches in the Concarneau region, leading to economic hardship and the migration of thousands of families. Canned goods prices soared, but couldn't meet demand. The crisis even led to a trademark dispute with Norway over "false sardines." Our final case study, Case Study 3, examines Hell's Gate and the sockeye salmon, focusing on human-caused environmental disruptions. Fraser River sockeye had a clear 4-year cycle of explosive catches, which C.H. Gilbert's research supported with the home stream theory. However, the expected big year of 1917 failed, attributed to a massive rock slide from railway construction blocking Hell's Gate. These early fishery crises spurred crucial scientific investigations into the causes of these significant resource fluctuations. Hypothesis 1 centered on changes in migration patterns. Earlier theories lacked evidence, but modern theory links migration shifts to water temperature changes. SARS's insight suggested ocean currents could move fish eggs, causing subsequent migrations to new areas and fluctuating fishing grounds. Hypothesis 2 explored the effect of predators. French fishermen blamed dolphins for the sardine decline, even requesting government naval support. However, Carl Moebius's pond experiment showed that the presence of predators, like pike, could surprisingly increase the overall production of carp. The early investigations set the stage for a critical conflict, determining whether fluctuations were caused by overfishing or by environmental factors. The sockeye salmon decline was debated as either an environmental disaster, the Hell's Gate obstruction, or the result of chronic overfishing. The late 19th century saw advancements in scientific methodology. Statistical foundations improved with the introduction of efficiency indicators like, catch per fisherman. Biologically, detailed investigations into fish age, growth rate, spawning time, and location became common. International cooperation became essential as fish ignore borders, leading to the establishment of bodies like ICES. Chapter 1 concludes with the lesson of history. The key takeaway is the inevitability of fluctuation. Ecosystems are dynamic and constantly change. The start of fisheries science is recognizing that ecosystems are not static. Economic interests clash with scientific advice, and short-term gains at the expense of long-term science can lead to fishery collapse.